Make the beep. Make the beep. There's the beep. So, I do spheres on their own because unlike all the other prisms that we have talked about, a sphere cannot exist two-dimensionally. Okay? A pyramid is just 4 triangles, flat triangles, and a flat square folded up, right? All the shapes we've done so far. Why are you here?
I'm in class.
When?
I told you like last week.
Then why are you here for the first time today?
He was here.
You were here before?
Yeah.
Do you sit back there usually?
Yeah.
That's why. Okay. So yeah, all right. I got you now. The only reason I asked Mason is because when I looked up your timetable today, because they sent that email about your binder, the timetable that I found had you in my class in second semester.
No, the one that I got.
Yeah, I understand that now. That's why I'm confused right now. That's why I'm acting confusedly, because I just looked at your timetable and had you in my class in second semester. So that's why I'm confused. I believe you. That's why my head is not working right now.
You just want to be here so much sooner.
Oh. Let me Neo out of the way of your growing nose. All right. Sorry. You get it there?
I get it. I just don't understand.
You lied, so your nose grew like a bullet, so I had to Neo out of the way of it.
I was lying. You really want to be in your class.
All right. Spheres do not exist in 2 dimensions, so I give them their own day. Because I don't do any time about, building them with blocks and folding them into origami spheres and things like that. Because we just go straight to the formula, right? And you just got to memorize. There's no way around it. The reason I give them their own day, though, is because they are complicated-looking formulas. But they can be dealt with in an easier way, okay? So the first thing we're going to talk about is a regular sphere. There are the formulas right there. Is there anything there that you do not already understand? We all know what an R is, yes? Right? It's the radius. Yeah. Now, since the sphere is just an infinite amount of circles, the radius is always the same from the center of the sphere out to the edge. Yes? Doesn't matter where we draw it. It's always R. Everybody cool? All right. So nobody has any trouble with R. And over here, I got another R. Nobody has any trouble with R. So we're good for radii, yes?
Yes.
Okay. So the question becomes, when you spend $4,000 on a computer and it doesn't work, when do you get angry?
You spent $4,000?
I didn't spend $4,000 on these things. Are you crazy? It's not Windows 10. I got Windows 10 on my desktop at home. Never does this.
Windows 10 's
Is this
good.
Windows 8 then?
No, this is Windows 10. It's the hardware. It's not the software. All right. So, spheres, no problem. Everybody's okay with spheres because the formula's right there. We all know how to fill in a formula. There's only one variable. There's not a length, width, height. It's not a hassle. It's super easy, yes? However, there is something we do with spheres. We stab people with spears. There is something we do with spheres that does cause problems. And that is hemispheres. What is a hemisphere? No. It's a half a sphere, yes? Which seems super easy to discuss, yes? If the surface area of a sphere is 4 pi r squared, and a hemisphere is half a sphere, then what do you think is the formula for the surface area of a hemisphere? 4 pi r squared divided by 2, yes?
No.
That makes perfect sense.
No.
Just stop giving me away. Does that make sense?
So hemisphere is
Half of a sphere, yes. So that would give us 2 pi r squared. Now Sam is over there going, no, no, no. Like that little bird from The Simpsons when Homer got super hyper obese and he used the bird to punch the computer and then it caused a meltdown. Yes, yes, yes. Sam, why is 2 pi r squared not correct? Right. Sam is saying that, Mr. Myers, if you cut off the bottom of this sphere and give yourself a hemisphere, what have you created right here? A circle. New surface area. Right? And Tasha, what is the formula for the surface area of a single circle? Yeah, you do. Yeah, you do. It's on the front page. Open it up. Right there. On the left. Pi r squared. So it's this, 2 pi r squared, but I have to remember to add another pi r squared. Now you guys are smart kids. What are 2 pi r squareds and one more pi r squared? 3 pi r squared. So there's a little gift for you. If you are faced with a hemisphere question, there is a formula for it. Ta-da! Excellent. Now let's look at the volume formula. Why does the volume formula bother you? What about that formula makes you go bleh?
It's asking for diameter instead of radius.
No,
Oh, no.
the volume formula.
Fractions.
The fraction makes you go, ooh, right? It makes you pee your pants a little. Not really, you're grown-ups, but... So we don't know. We never do that. Aiden, please say that aloud again. We never change it to a decimal. Why? Why is it wrong?
Because it makes it a big dodgy decimal.
Because it's 1.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333No. That's my... Yes. That's my point, right? It never ends. So we leave it as a fraction. But fractions bother people on their calculators. But we have seen something like this before, haven't we? What was the volume of a pyramid? On your sheet, it was 1/3 area of base times height, yes? But I gave you a shortcut there. What did we do instead? We did area of base times height divided by 3. So we're going to do the same thing here. We're going to write this as 4 pi r cubed divided by 3. That is the way I recommend you write it. Don't worry about the fraction. Now, if you're comfortable with fractions, go ahead and use them all you want. Okay? Now, next question. Hemisphere. How do I do the volume of a hemisphere? A hemisphere is what? Half a sphere. So if I cut it in half, am I adding anything to the volume? No. So all I got to do is cut this in half, yes? So technically, I am doing 4 pi r cubed divided by 3 divided by 2, aren't I? That's barfy. Because what that is in math is 4 pi r cubed divided by 3 divided by 2. Blech! What's the easier way to deal with fractions and make them divide by 2? Nope. If I have $10 and I divide it by 2, what do I get? $5. If I have one of the very rare, but they do exist. If I have one of the 50-cent pieces, that is $50, yes?
Those are rare.
Yeah,
I have one.
they're very rare.
I have a $2 bill. Oh, like a Canadian one or an American?
Canadian one.
Oh. My dad has a Canadian dollar bill.
Yeah, I do too. I just saw. I was at a bar down in Seattle or in Ocean Shores where they staple money up on the walls that people leave, like all the tourists, and there was a Canadian $1 bill there. And I was looking at, and some other guy was looking at some American. He's like, wow, I didn't even know Canadians had a $1 bill. I thought they just had those stupid little coins. So then I was able to talk to him about it. Because, of course, the dollar bill makes way less sense. The dollar bill is stupid. Yes, it is. The dollar bill is idiotic. They're made of paper. They get ruined all the time. And when you reach into your wallet in America and you open it up and it's full of green, you're like, yeah, I'm rich. And then you start taking out all your money and it's ones. It's $10.95. Okay, hit 1, 2, 3. And they don't even have $2 bills down there, those idiots. No, they do still have $2 bills, but they're very, very rare. They're considered bad luck. So, we're not really dividing by 2. What are we really doing? Multiplying by a half. So what do we get? 4 pi r cubed times 1, which is 4 pi r cubed over 6. Now, Sam said, well, wouldn't 2 pi r cubed over 3 work? Wouldn't it? Isn't 4/6 the same as 2/3? Is it? Yes. So would it work? Yes. The reason I show it is because if we get crazy decimals and stuff, this one keeps you with the 4 pi r cubed, which you're used to seeing. That's why I recommend you use this one. Okay, Sam? I wasn't trying to say you were wrong. I'm just saying we're used to using 4 pi r's with spheres, so I like to keep it there. Cool? Tasha.
Is that like 6 into 6?
6.
That's 6?
Yep.
Straight up 6?
Straight up 6. All right. So now, since all we're doing is filling in formulas, I've kind of changed how I'm going to do this question because we filled in enough formulas, right? Everybody knows how to do it. So what we're going to practice on this question is we're actually going to practice some algebra instead. And it's going to give us a chance. Well, it's difficult to finish a sentence in this room, Jake, because everybody has to feel that they deserve to get their little bit out. So every time I say something that somebody doesn't like algebra, people have to give their opinion on it, which kind of stops the class. It's a little frustrating. Hopefully the people that do that all the time are hearing this conversation you and I are having and will figure out that it means I want them to stop doing that. But I bet it doesn't help.
Okay.
So, we read this question, which is, of course, a stupid math class question because you would never wrap a basketball. Right? It's a pretty stupid thing to wrap. Here.
I wonder what it is.
What could it be? It's a globe. Right? So anyway, but it's a math class, so we're going to pretend that you would actually wrap a basketball as a ball.
Yes.
So, since we are wrapping the outside of the ball, is it surface area or volume? Surface area. Surface area equals 4 pi r squared, right? Now, normally, we would be given the radius and we would find the surface area. But we've done that to death. And it's time I learned I need to check if you guys can indeed do algebra. So, what do we have here? Do we have the surface area or do we have the radius? So, we got to put in 2,500 over here, 4 pi r squared. Now the question becomes, do you remember your grade 7 algebra?
No.
What's your job in algebra? Brianna. Yeah, you want to isolate the variable, which is the proper word for it. But every teacher has a different way of saying it, right? Let's get the letter alone. Let's separate them. Like everybody's got their own thing, right? But what they're doing is they're saying isolate the variable. Isolate means get it alone. Variable means it's the letter. So let's isolate this variable. How do you isolate a variable? It means you got to move stuff away from it, yes? So, if I wish to move stuff away in math, what process must I use?
Division.
In this case, it is division. Why, Tasha?
I don't know, I just remember that.
Okay, Aiden.
Because there's the right beside each other, so therefore you would multiply it if you're doing the equation properly.
Exactly.
So you want to do exactly the opposite.
This is asking me to multiply 4 times pi times r squared, right? But I can't do that because I don't know what r is. So I have to work backwards. And backwards of multiplying is, Tasha? Division. So what must I divide to make this r be by itself? I must divide by 4, and I must divide by pi. What will happen to those 4 and those pi's on this side? They don't cankle each other out. They don't have ugly legs. They cancel each other out. Cankles are the worst. My wife has cankles. I feel sorry for her. She's such a beautiful lady, but she has cankles.
Wait, what are cankles?
They're when your calf goes straight into your ankle. You don't have one of these. Calf, ankle. It's just...
My store manager has that with his earlobe.
What?
He has earlobe cankles?
They just like go straight.
I know what you're saying. That's called an attached earlobe. Some people have that. Like most people have their ears turn up a little bit. That's called an unattached earlobe. That's the dominant trait. Most people have that. But some people have attached and it goes straight down. And it looks a little weird the first time you see it.
But his is like really down.
Yeah.
It really almost goes down to his chin.
Yeah. Yeah, it is. It's weird the first time you see it. You're like, ew, what's wrong with your ears, dude? They're just my ears. Why you got to be that way? All right. Okay, so if I do something to the right side, what do I got to do to the other side? Same thing. Right? Now, here we are at a choice. I could use my calculator to find that number. Okay? And then r squared would equal some number. Yes? Now, what is the problem with that? 4 pi is yucky, isn't it? Because pi is going to be a big, crazy decimal. Tasha?
How did you know to do the 2500 over the...
Well, because the 2500 was already there. Because it looked like this originally, right? And then once I divide something on one side, if I don't do it to the other side, it won't be equal anymore. Remember that? Okay, so everybody's cool? So I could get the number there, but it would be big and ugly. But I need you guys to learn how to get that number there. So are you going to be able to do that in your head? Of course not, right? But you could get an idea, right? Here is why I want you to get that idea. If you punch this into your calculator wrong, you're going to get an answer, right? If you do some work on your calculator, push equals, your calculator is going to give you a number, isn't it?
Yes.
Okay, so wait. Nick says 795. No, just Nick, there's a reason I'm talking about this. Just stay cool, okay? Nick used his calculator and got 795, right? Now, Nick, your calculator says 795 right now, right? Yeah. Do you believe it?
No.
You shouldn't believe it, and here's why. Before you even punch this into your calculator, because it's a little complicated, what should you do? I warned you to do it at the beginning of the year. I said, make sure you do this every time.
Double check.
No, before you double check.
Get rid of pi.
No.
Reverse it.
No.
Eat some pie.
Well, that's always that's always good advice, Tash. You should always eat some pie. No, what you should do is you should have an estimate so you have an idea of the real answer, yes? What is pi really? 3.141596. What's it close to?
3.2.
Closer.
3.
3. What's 4 times 3?
12.
12. What's 25 close to? 24. What's 24 divided by 12? 2. So this should be around 200, shouldn't it? So when Nick punches into his calculator and gets 795, should he write 795 there?
Whoa.
No, because he knows in his head. Common sense says this answer has to be close to 200. Right? Right?
Yes.
So everybody try to punch that into your calculator.
Calculator.
If you've already done it while I've been talking, that's fine, Sam. You needn't announce everything you're doing, okay? I'm about to write something down. This is 2,500 divided by 4 pi. Now, Does everybody have the exact same calculator?
No.
No. So can everybody punch this in the same way? No. Whose responsibility is it to learn how their calculator works? Yours. So figure it out. Everybody should be able to get 198.94 something.
3, 6,
Oh,
7,
yeah.
8.
I don't need that.
Oh my God.
Okay?
Yes.
Brianna.
Well,
Yeah. I'm glad that happened because it allows me to show you something. So Brianna says her calculator, she punched in, she did 2,500, then she pushed the divided by button, then she pushed 4. Did you push times or just 4 pi? 4 pi. Now your calculator knows, her calculator knows that that has times right there when you bump 4 into pi. Everybody cool? Okay. Now, according to her calculator, because can her calculator think? Think real closely about your answer. Does your calculator think?
Yes.
No. Your calculator does no amount of thinking. Thinking means it is making a decision. Is your calculator making a decision? No. Your calculator follows math rules. What are the rules of math when you line up a bunch of arithmetic? Bed mass, which says brackets, exponents, division, multiplication, addition, subtraction, yes? So this problem has division and multiplication in it, doesn't it? Right? And your calculator knows that division and multiplication are done at the exact same time, except it's impossible to do them at the exact same time, so we go left to right, don't we? So when Brianna punched this into her calculator, what her calculator did was it took 2,500, divided it by 4, which is about 650, and then multiplied it by pi, which is 3.14. 650 times 3 is 1,900. So, how could Brianna tell her calculator, I don't want you to do that. What can she use to make this work? Brackets. Where? Around the 4 pi. Is everybody cool? Could everybody get their calculator to show them 198.94? Brianna, yours will now. Not divided by pi. If you did 2,500 divided by 4, then pushed equals. Oh, no, that would work. Yeah, that would still work. Yeah. Now, what is our last step here? How do I get rid of this? Oh, sorry, Nick. What? Okay. What's our last step? How do I get rid of a square root? How do I get rid of a square? You square root it. So if I square root this side, what do I do to this side? Square root. And I get something like 14.1.
So 14.
Is everybody good?
Yeah.
Everybody remembers algebra?
Yeah.
Everybody remembers how, or is starting to learn how their machine works, yes? Okay. Turn the page over. Let's try this next problem. Again, this is a math class problem. It's not a real life problem. Read the question. And tell me in words, not in numbers, in words, what we are doing. Excellent. We have volume. Why is it volume, Nick? Because I'm filling stuff up, right? So I'm caring about the space inside, right? So I have the volume of what shape? But box isn't a shape in math class. It's a cube? It's right. Volume of a rectangular prism, right? That's one thing I care about, yes? What's the other thing I care about? Volume of the golf balls. How many are there? 3. So it's the volume of 3 spheres, yes? And what am I going to do with those two numbers? Why am I going to subtract them, Sam? because I want to see the empty space. Now, this seems like a math class problem, doesn't it? But it absolutely isn't, because everything you buy is packaged, yes? Somebody figures out how that gets done. It's not done by computers. So, we say, Sam says it's subtraction, yes? So now, can we put in some numbers? Okay. Yes, Brianna? Oh, volume of a rectangular prism, because that's the box. You know, people say, it's so sad when you're at Yale and you're in those rooms with no windows. It's so sad, it's so cruel to the kids to have them in a room where they can't see out. It's just not right. No, because you people can't pay attention to something for 5 seconds. Oh, it's raining. I live in southwestern British Columbia where it rains 180 days a year. Oh, it's raining. Look at that, it's raining. I've never seen rain. And in December, you know what's going to happen, Nick? It's going to snow. And you guys are all going to sit here. I've never seen snow. Oh, wait, except last year when we had 4 feet of it twice. And then in spring, it's going to be sunny. Oh, it's so sunny out there. It's amazing. When I taught in Williams Lake, the kids were like that. It's snowing. Oh, my God. It snows by Thanksgiving every year here. It's nothing new. No, it sucks. All right. What is the volume of a rectangular prism? LWH. What is the volume of one sphere? 4 pi r cubed divided by 3, right? But how many are there?
There's 3, so you don't need to divide it.
There's 3, so what do I get to do with the 2 3s?
You just kick it out of there.
Cancel them out. Now, guys, you always say to me, Mr. Myers, why do you make us show work? By showing this work, didn't we just make our work easier?
Yeah.
Because we got rid of the division. So what do we have to do? We have LWH minus 4 pi r cubed. No division. What's the LWH? 3 times 3 times 9 minus 4 pi. What's the r? It's a trick.
Oh, it doesn't have.
What's
Look, that's how many golf balls it has.
1.5 cubed.
Oh, Sam, you're a silly goose.
Now you punch that into your calculator. 81. Now this is a little bit difficult. If you have the x cubed button, it's very easy. But if you don't, you got to remember how to do exponents on your calculator. On whose calculator? Your calculator. It might be this button, x with a y. It might be this button, y with an x. It might be a caret. It might be, I don't know why it's called a carrot. It's not spelled the same as the vegetable, though. It could be x with a blank. Yes?
Get the 1.5.
Well, if the golf ball fits in there, it must have a diameter of 3, yes?
Yeah.
And what's a radius?
Half of that.
What's half of 3?
1.5.
So where did I get the 1.5? So, what's the answer? Well, that depends. Depends on how far you want to take this, right? If you wanted to get the perfect answer and all the full marks available to you on a test, how much should you show me?
All of it.
At least to here. Now, should I stop for a moment and do a quick estimate? 4 times 3 is 12. 1.5 times 1.5 times 1.5. No, it's not much more than 2. Right?
3.375.
It's 3.375, okay. So 12 times 4 is 48, right?
Yes.
So my answer should be around 81 minus 48. And what do you get? It's not too bad, right?
I got 38.6.
That's the answer. 38.6 is the right answer. Is that fairly close to our estimate?
Yeah.
Right? Not like when Nick made a small mistake and wrote 800 when our estimate was 200. Right? So you subtract this out. You do this on your calculator. You can't do it in your head. And it comes out to be something like 35 or 34 something. And you get an answer of 38.6, was it, or 36.8? I can't remember. Which, Jack, what was it?
38.
38.6.
See, I didn't get that fully. I just did the 4 times pi minus 1.5 r.
Yeah, which got you, and then you were going to subtract it later. Yep, okay. I want to call your attention to one more feature on your calculator that a great many of you are not aware of. Look on your calculator, not on the buttons. Yes, Nick? I'll get to that in a sec. I'm about to show you actually on this calculator. So, on my fancy calculator, 81 minus. Everybody okay with that so far? 3 times 3 times 9 is 81. 4. Now my calculator allows me to go 4 pi. Just put it right together. I don't need to push times. Okay? But you might need to push times. Then times. Now I'm going to put this in brackets. 1.5 exponent 3. And I'm going to close the brackets. Does everybody see? 81 minus 4 times pi times 1.5 cubed. Everybody good?
Yeah.
So I can push enter, and I get my answer, 38.6. Everybody okay?
Yeah.
Now, stop for a second. Exactly. Some of your calculators are going to give you problems. If you can't do it all in one step, what should you do?
First, you probably want to do the 81 minus, you want to figure out the 4 pi r.
Yeah, you can do the 81 in your head, but let's say you can't. You would do it. You go 3 times 3 times 9, right? 81. Then you go to your calculator and you go 4 times and you figure it out. Okay? Now here's the thing I wanted to show you. Let's say I have to do it in steps, right? So I'm going to go 4 times pi times 1.5 cubed. Everybody cool?
Yeah.
Okay. Now this is a big yucky number, right? Most of you don't have my calculator. It has a whole big screen, do you? How many lines of info are on your calculator at any given moment? 1. If most of you push another button, you're going to lose that number, aren't you?
No, just go to answer.
Yeah, but a lot of people don't know that feature, Jack. That's what I'm trying to explain right now. So if you have a calculator that disappears your work, I'm going to disappear my work, so it's gone. I know that it's 81 minus whatever that was, right? So I can go 81 minus. Now look closely at your calculator. Written right down here on my calculator, not on the button, as a second function, is ANS. That stands for answer. Your calculator holds the last thing in its memory that you pushed equals for. So the last thing we pushed equals for was 42.41, wasn't it? Right? So if I go 81 minus answer, enter, it remembers that answer for me. So I don't need to remember it. Okay? Almost all of your calculators will have an answer feature on it. That's why I said almost, TJ. If it doesn't have an answer feature on it, you gotta show the work. You gotta write 42.41 here. Okay? Is everybody good? I'll come back and look at yours in a sec, TJ, because I think yours does. Oh no, that one won't. Oh, maybe. I'll come look. Yours definitely does. Alright, is everybody good? Jake?
Mine said pre-answer.
Pre-answer?
It says PRE and then ANS.
Oh, that's because the PRE is something even different. Yeah, pre-answer, previous answer. Yeah. Is everybody good? Okay. Please start working on the rest of that assignment. I think it goes up to 33, but I'm not sure. My computer's frozen, so I can't tell. Oh, more. 36?
Yeah, 36 has one sphere and one cone.
Okay, go up to 36. Oh no, 37. Keep going. What's the next page? 38. Up to and including page 38. That's what we're working on now. Yep. Whatever it's asking for. Yeah, no. On 35, I want you to vote just for that question. Okay? Just surface area. So you guys are doing 35 to 38. Please notice the next thing on the list is a quiz.
Oh, that's a spicy meatball.
When will that quiz be?
And the end of class.
Thursday, because we're going to go over all this work tomorrow, give you yet another chance to say, I don't get it, I need help. And what is your Thursday class after? So where should you be at X Block if you still don't get this stuff?
Right here. in Miss
How do you
Ryan's
get signed up in my
You
class?
write your name on there.
C, X Block,
I do see.
Kathleen.
One sec, or Nick, I'm just writing it down. Quiz on surface area and volume
Oh
Thursday.
no. Is it multiple choice?
Maybe.
Oh no.
Maybe it isn't.
Oh no.
You really don't have an answer? Oh no, this is easy. You gotta get it. Come on, get your Oh, wait. Yeah, kind of.
No. Yes, I am.
Sorry, Jay.
Yeah, but I don't want to wear that.
Did it break? Jay?
Summer's so much more quieter.
Chloe, Miss Brenda.
Because like, are you
This is about the first. So yours actually is easier to learn. A string of calculations. Right? You do it all in one shot. Right? Do the
'cause
But you did the formula right. What? Whatever you want. Whatever you need, Student! Yeah, but there'd be some decimals. Yeah. Well, you might you could even if we had so damn close. If you left it at 75.98, I'd be happy with that. Okay? Alright, you. You're doing well. Let's check. Come on, Jack. You were in my class all last year and never once did fingering. I brushed against his back with my elbow because he is sitting very close to Tasha's desk.
I was assaulted by a teacher.
There are people that would claim that.